Hello friends, as you know, the traffic shaping that is nothing but to control the number of packet transmitted. So basically we're going to decide the data rate. So traffic shaping is achieved by the different technique. For example, leaky bucket and the second is a token bucket. So let us discuss about this technique in detail. So let us start with the traffic shaping. Once the traffic is admitted to the network through the admission control function, as you know, we are going to put the restriction, the number of packet entered into the packet. How are we going to put that restriction? We're going to put the restriction with the help of admission control function. The traffic shaping practice are used to control the volume of traffic entering in the network and the rate at which the packets are transmitted. So, with the help of traffic shaping, what we can put the restriction? We can put the restriction on the number of packet enters into the network and the number of packets transmitted in the network. So, we put the restriction at the both the points. In this way, the flow of packet is smooth according to configured profile of the traffic load on the network. So basically, we're going to smooth the traffic transmitted. We put the restriction over the number of packets sent. The traffic shaping can be implemented using a leaky bucket filter. So basically for the traffic shaping, we are using the different techniques. So that is one of the technique is a leaky bucket. The bucket is essential to regulate the queue. So basically with the help of queue, with the help of leaky bucket, we can regulate the queue. Queue means number of incoming packets and the number of outgoing packets. A traffic source can produce a packet at the quite unsteady and unconstant rate. So the packet arrival rate, we can't control on the packet arrival rate. It sometimes you will may get the bursty traffic, you will get the regular traffic. So here the incoming packet, it can be at uncommon rate or unconstant rate which trickle into the bucket. So all that is collected into the bucket. The packet flowing into the bucket are spaced out in the steady way at the fixed rate. But whenever that packets are going out, it will be go at the constant rate. Whatever your incoming rate, but your outgoing rate will be the constant. Now we can imagine the bucket has an imaginary hole in the bottom and the packet can trickle into it is an analogy with the real bucket full of water with the hole. So basically that a leaky bucket means what? Here there will be a big bucket, at the down you will get the hole. So the water will trickle out the bucket little by little independent of how quickly bucket is filled up. Now see here, all the bursty traffic is nothing but your water, which is trickle inside the water. So all the bursty traffic, it gets collected into the bucket. So using the leaky bucket filter does not allow the sending of the burst packet, but only at the specific rate. So what I'm saying here, whatever your incoming packet rate, your outgoing packet rate is fixed over here. The outgoing packet, you can't send the bursty traffic. If there is no traffic for the certain period of the time, the amount of unused bandwidth cannot be used for the latter packet. This is achieved by using the token bucket filter. So basically in the leaky bucket, what you are getting the constant rate, but sometimes it may possible that you don't have the data to send, your host will be idle, so that resource we can't use to send the bursty traffic. So with the help of another technique that is called as a token bucket filter, it is possible to send the burst traffic also. So now let us discuss with the leaky bucket, the technique number 1. If a bucket has a small hole at the bottom, the water will leaks from the bucket at the constant rate as long as there is a water in the bucket. So as you know, if we take a water, there is a hole at the downside, and then the water will leak at the constant rate. So the rate at which the water leaks does not depend upon the rate at which the water is input to the bucket unless the bucket is empty. Now see here, now your outgoing rate is not depend upon your incoming rate. So what is over here, whatever your outgoing rate is independent on the incoming rate of the packet. The input rate can vary, but the output rate will remain constant. So just now we discussed the incoming rate of the water. It will does not affect the outgoing rate because there is small hole and the water will leak from that hole. That speed will be constant. It will not depend upon how much amount of water is coming from the input port. So same over here in the packet case, whatever the your incoming data will is coming with the constant speed, whether it is coming in the burst speed, your outgoing rate will be the constant. Similar in the networking technique is called as a leaky bucket can smooth out the bursty traffic. So with the help of leaky bucket, you can smooth out or you can keep the outgoing rate at the constant level even your incoming data is a bursty traffic. The bursty chunk can store in the bucket and send out at an average rate. So figure shows the leaky bucket and its effect. Now see, whatever your incoming rate, your outgoing rate will be the constant. So now let us discuss with the help of example. So this is the example over here. This is the leaky bucket. Now over here there is a small hole. This is my incoming data. So the incoming data is of any rate. So that because of that we called it as bursty flow. But whenever my outgoing rate, can you see this is a fixed flow? So let us discuss about this. In the figure, we assume that the network is committed bandwidth of 3 Mbps for the host. Now see here, I did commitment with the client that you will get the rate of 3 Mbps. So the user has to get the rate of 3 Mbps. That is the commitment. The use of leaky bucket shape the input traffic to conform to this commitment. So basically, with the help of leaky bucket, you will achieve the specific rate. In the figure, the host sent the bursty data rate 2 Mbps at the 2 seconds. It sent the 2 Mbps for the 2 seconds. Now see here, this is the bursty data information. My user sent the 2 Mbps data for how many seconds? 2 seconds. So total data send is 24, that is nothing but 12 into 12 megabits per second for 2 seconds. So total will be 24 megabits of data, and then the host is silent for 5 seconds. Now see here, till next 5 seconds, my host is not sending any data. And then the data rate of 2 Mbps for 3 seconds. Then how much data he sent? He said use the 2 Mbps for 3 seconds. For total will be 2 into 3 is nothing but 6 megabit of data. So in all, it sent as a 30 megabytes of data in the 10 seconds. So now see here, for next, he sent the 2 Mbps of data for the next 2 seconds. For next 3 seconds, that is 10 to 7 to 10. So combinedly it is a 3 seconds. So this data will be what? 6 Mbps, and this is nothing but 12 into 2. So it will be 24 Mbps. So how much he is sending? 24 plus 6 is nothing but 30 Mbps. And for how much second? Till 0 to 10 seconds. So in the 10 second, he sent how much data? Entirely he sent the 30 Mbps data. The leaky bucket smooth the traffic by sending out the data rate at the 3 Mbps. Now see here, but at the fixed data rate, how much data rate you are getting at the output side? You are getting at the 3 Mbps. Even here you are having the different speed. Over here you are having the different speed. But at the output you are getting the constant rate, that is 3 Mbps. Without the leaky bucket, the beginning burst may have hurt the network by consuming more bandwidth than set aside for the host. So just now we discussed at the first time between 0 second to that of 2 seconds, how much bursty traffic come? 24 Mbps. If we are not using this technique, then what will happen? Then it may possible that it consume the more bandwidth. So we can see that the leaky bucket may prevent the congestion. So if the many packets come at the same time, there will be a chances of congestion. So with the help of leaky bucket, we are avoiding the congestion. As the analogy, consider the freeway during the rush hour. So now let us consider the example of freeway. In the peak hour, what happened? You get the bursty traffic, means lot of incoming vehicles. If instead the commuter should stagger their working hours, the congestion in our freeway could be avoided. Now in this case, the commuter which are walking randomly, what will happen? But the my incoming data rate whatever it is, but at the outgoing speed will be constant. How much is road, that according to that only you will get the outgoing vehicles. A simple leaky bucket implementation is as shown in the figure. FIFO, that is first in first out, queue hold the packets. If the traffic consists of fixed size packet, the process will remove the fixed number of packet from the queue at each tick of the clock. Now see here, this is the queue, this is a processor. Now let us discuss about the leaky bucket algorithm. First we'll discuss about the implementation. So the first packet will first out. So FIFO means first in, first out. There is no priority assignment over here. Whichever packet come first, it will be go first. Here, as you know, in the leaky bucket, the fixed amount of the packet processing is done. If the traffic consists of the variable length packet, the fixed output rate must be based on the number of bits or bytes. Now, how to achieve this? So, for that, there is a one algorithm. This algorithm is used for variable length packet. If your packets are coming at the constant rate, then it will not make a large difference. But if there is a variable length packet, then how the processing has been done, let us discuss about it. Initial the counter to n at the tick of the clock. Now see here, this is my counter which is nothing but n's. We set that value. And now every time if n is greater than the size of the packet, it will send the packet and decrement the counter by the packet size. Now see, every time the n is going to compare with the packet size, and if that less than that of packet size, then it will store that into the queue, and this process will continue till this value is become less than that of this value, and this process will repeat until the n is smaller than that of packet size. Once it becomes the smaller than the packet size, it again set that value. So reset the counter and go to the step 1. So again then it will start taking the packet and it will reduce the counter by that of packet size, and when that counter is reduced below the packet size, again we reset that value and we will go to the step 1. Now let us discuss about what are the disadvantage. The leaky bucket is very restrictive. It does not credit and the idle host. So basically it is very restrictive, means it will provide you the one constant data rate. For example, if host is not sending for a while, its bucket become empty. Now, if the host has a bursted traffic data, the leaky bucket allow only in the average rate. So now sometimes may happen that host does not have the data to send. So at that case, it will be idle. In sometimes it may possible it having the bursty data, but still it will provide, in both the case it is providing you this constant rate. The time when the host was idle is not taken into account. So basically, the whatever the time my host is idle, we are not going to consider that time. So basically, we are we are not utilizing the resource properly. My host is idle means what? You are wasting the resource. So now let us come up with the next technique, that is a token bucket. So basically, as you know, the leaky bucket provide me a constant data rate. Even my the incoming data is a bursted traffic, it is a normal traffic, it will give you the constant data rate. Now to handle the bursted traffic, we come up with the next technique, that is called as a token bucket technique. On other hand, the token bucket algorithm allows the idle host to accumulate the credit for the future in the form of tokens. So basically here in the token bucket, if your host is idle, then that token is get collected, and whenever there is a bursty traffic, at that time you can may use that token to send the bursty traffic. For each tick of the clock, the system send the end tokens and to the bucket, then system will remove one token for each cell of the data. So basically what happened, whenever in the single tick you will get the n amount of the token, and when you send the packet, at that time each packet will consume the one token. For example, n is nothing but 100. So how much token now? Right now I have the 100 tokens, and the host is idle for the 100 ticks. So till 100 ticks my host does not have the data to send. And how many tokens are accumulated in the bucket? So it is nothing but 100 into 100. So how much? Now I have 10,000 of tokens collected in the bucket. So now the host can consume all this token in the one tick. So even in one tick, my host can consume all these tokens. So now you can send how much packets? That is 10,000 cells, or the 10,000 packets you can send in one tick. Or host take 1,000 ticks with the 10 cell per tick. Otherwise, in each tick, it can send how many packets? It can send the in 10 packets. So according to the user requirement, you can send the packet. You can send the lot data at one time, or you can send the little data at the some time interval. That is depend upon the your requirement. On other word, the host can send the bursty data as long as the packet is not empty. So now, as you know, when my bucket is empty, means when I don't have token, at that time you can't send the packet. Now I have the 1,000 of token, then I'll send the thousands of packet. So here you can send the bursty data. How many token is there in the bucket? According to that, you can send the data. A finer way to implement the traffic shaping, use a token bucket filter, which allow the burst of the packet to be sent every now and then. So as you know, your entire sending is depend upon how many tokens is there in the bucket. You can send the bursty traffic as well as you can send the normal traffic. That is depending upon your requirement. The token bucket filter is a way to implement both the admission control and the traffic shaping. So basically here you are controlling the admission, means how many packet will come inside the network, How you going to control? By putting the number of tokens. If I want that only 100 packets should be entered, then I'll put only the 100 tokens. So here you are controlling the admission of the packet as well as the traffic shaping, and how much data to be go out, that also you are controlling. So you are controlling traffic shaping also, and you are controlling the admissions also. A philosophy is same that the leaky buckets one. However, the token of the bucket allows having a permission to send the burst of the packet. So whenever you want to send the bursty traffic, at that time the tokens are accumulated. At that time you can send the bursty traffic also. A figure show the token bucket scheme. The algorithm is every certain period of time which determine the rate of packets are served and the token is served. So now let us discuss this with the help of example. Now this is my token bucket. Now here the packets are coming, and then once the packet comes, the one token is removed. So how many token now there are 4 tokens. So now let us discuss this example in more detail. Each token can associate to one packet in general to define the quantity of the data. So as you know, once I send the one packet, the one token is get consumed. When the packet is sent, one of this token is removed. If there is no packet to send, the token can be retained and can be used for the new packet later on. So it may possible the tokens are get collected into the bucket, but you don't have the packet to send. At that time, that coupons or the tokens are accumulating, and in the future use, you can use that tokens. In figure, the 4 tokens are retained in the bucket. So just now we discussed in the token bucket how many tokens are there. Only the 4 tokens are there. Hence, the sudden burst of the 4 packets can be served and allowed to go through the network. Sudden the burst data. Now let us consider the suddenly the 4 packet comes. So my network will allow you to send the 4 packet because the 4 tokens are there in the bucket. When the packet arrives and there are not enough tokens retained in the bucket, the action can be a various according to how the token bucket filter is configured. So now let us consider the packets are there, but the tokens are not there. So how the packets are going to treat, that is depend upon how you configured that filter. The packet can be buffered and not discarded until the new tokens are available. The packet can be marked and hence treated in the particular way the packet can be discarded. So now how much what policy you are implemented, it is depend upon that. For example, if there is no token, then discard the packet. If you put this policy, then it will work accordingly. And if you put the policy, then it will wait for the new tokens to come. It will depend upon how you configured that token filter. So now this is my token filter. How many tokens are there? 4 tokens are there. So once the packet is gone, the one token is get removed and then packet is forwarded. So here with the help of this, you can send the 4 packet. So we can see why the token bucket filter implement both the admission control and the traffic shaping function. So just now we discussed with the help of token bucket, you can put the restriction on how many number of packets enter as well as how many number of packet will exit from the network. If the packet arrive at the rate exceeding the maximum allowed rate for their service class, only the number of packet matching the number of retained token is admitted to the flow into the network. Now how we put the restriction on the admission? How much packet you want to be written on the network, only that many number of token you're going to put. At the same time, the rate at which the packet is sent is shaped as the tokens are accumulated at the specific rate. So how much token you're going to put per time, per seconds. So with the help of that, you can also define what will be the rate of packet transmitted. If you want the low data rate, then the number of token collected will be less. If you want the more data rate, then more token is going to be placed per second. So you are defining, you are restricting the data rate also and the incoming packet also. Now, as you know, the both the technique having their own advantages and disadvantage. And now I want to combine both the advantages. Then the combination is also possible. So combining the token bucket and the leaky bucket. The two technique can be combined to credit the idle host at the same time they regulate the traffic. So basically here we are combining both the advantages. We are regulating traffic as well as the whatever the disadvantage of the leaky bucket, that is idle host, that also we are removing with the help of this technique. The leaky bucket is applied after the token bucket. So whenever we are doing the combining both the technique, at that time the first you have to put the token bucket and then you have to put the leaky bucket. The rate of the leaky bucket need to be higher than the rate of the token drop in the bucket. Why is it so? Because you want the rate of the leaky bucket should be higher than that of rate of the token drop in the bucket. Thank you.